Good evening, everybody. Welcome to Chem 1211 with your host, me, Dr. White. And I'll be going through quiz number 4 review. Let me remind you that quiz number 4, I'll be giving this Thursday, and it will at 8 a.m. I'll send out the password for the PDF file that's located in Blackboard assignment area. You'll have until Friday, 8 p.m. to take quiz 4 and upload your answers. Remember, I reserve the right to subtract 25 points for anybody who does not follow instructions or does not upload your quiz on time. However, if something comes up, email me before that if you need a little extra time, because life happens. All right, quiz 4 has 5 pages. 13 problems, and I have 5 multiple choice, and it's worth 50 points along with five bonus points. And it covers chapter 12 and parts of chapter 13 that deal with solutions. Now, by Sunday, I'll have it posted in there, and I'll do like I always do. I'll send out an email that has the points you get for each answer on quiz 4 in this case. All right, let's get going. Now, quiz 4, and what you're seeing is in the lecture section of Blackboard, cleverly named Chem 1211 Quiz 4 Review. I have both Word and PDF file. Now, the first thing you should know, there's certain definitions you should know. And that is a solution contains one solvent, but one or more solutes. What's a solvent? The component of a solution present in the greatest amount. What's a solute? The other components of the solution. Now, if we look at chapter 12-13 solution practice problems, is the answer key. If we look at number 3, a solution has 12 grams of KBr, potassium bromide, and 10 grams of water. What is the solvent? What is the solute? Well, the solvent is the component present in the greatest amount. In this case, KBr. And the other component, in this case, water, is the solute. So the solvent is always present in the greatest amount, and the other components are called the solutes. Now, something that looks like a solution, but it's not, is called a colloidal dispersion. And this is actually particles, very tiny particles of one thing, dispersed in another compound, usually water, but not always. And it's not a true solution. How do you know it's not a true solution? Warning, warning. Dr. White's going to get one of his favorite flashlights out. One of my favorite ones from, ooh, it's bright too. By the way, it's variable brightness. And it's got red and white. Anyways, how do you know something is a colloidal dispersion? Well, a colloidal dispersion won't pass light through it. If I had sugar, which I don't, or salt and water solution, I go like this and it passed through. If I had a colloidal dispersion, like mayonnaise, and I did this, the light wouldn't pass through because the little particles in there that are not dissolved, they're just floating around, block the light. By the way, this is one of my favorite. I actually have 4 different types with different LEDs in it. And this is made by Hank Wang, who's probably the premier flashlight builder right now, or one of the 2 or 3 best in the world. Hank lives in China, has a one-man place and does some fantastic work. I got my flashlight stuff in. All right, so you should know colloidal dispersion. Now, I don't have here, but I talked about it. What are some examples of colloidal dispersion? Well, let's look at and here I ask you, give an example of a colloidal dispersion. Well, latex paint is an example. Milk is an example. Your blood, and don't try shining a flashlight through blood, please don't. Also is a colloidal dispersion. And I believe if you could also say ketchup and mustard are also. All right, now I also have here, you should know what is examples of solutions. Well, I'm a former tea drinker. I had to give it up because of caffeine. I don't like decaf tea. And pop, remember Dr. White's from Chicagoland, and that's the carbonated beverage you buy in a can or bottle that's non-alcoholic, like Dr. Pepper, Burners, and other things. And if I mix sugar and water together, that would be a solution. And the air you're breathing is the solution. Now, an important concept when it comes to solutions is like dissolves like. And what that means is like solutes are soluble in like solvents. And what we have when we say that, there are 2 types of designation, polar and nonpolar. Excuse me. So like dissolve like, polar solutes are soluble in polar solvents. Nonpolar solutes are soluble in nonpolar solvents. An example you should know, water, alcohols like ethanol that you drink, I'm saying you have to, or rubbing alcohol, which is isopropyl alcohol, and salts like sodium chloride and other salts are polar. Examples of nonpolar things are vegetable oil, gasoline, Vaseline, baby oil, and it's interesting, dirt and grease are nonpolar. And if you take my organic chemistry, you learn how organic chemistry helps you get grease and dirt off your hands, usually using the concept like dissolves like. Now, what does this mean? If I have compound X and it's soluble in water, but not soluble in vegetable oil, what polarity is it? We've got 2 choices, polar or nonpolar. And let's write that down. I'm going to abbreviate tonight. Compound X is soluble in water, but not soluble in vegetable oil. All right, So compound X is soluble in water, but not soluble in vegetable oil. What is the polarity of compound X, and how do you know that? Well, water is polar, vegetable oil is nonpolar. Since it's soluble in something polar, but not nonpolar, we know compound X is polar. And how do we know this? Because we know like dissolves like. And you should know how to do this. All right. Now, there's some terms you should know and understand. And the first one is solubility of a solute. And that's a number you would be given, or you can calculate if you're working in a lab sometimes, but many of the things are already known. That's the maximum amount of solute that will dissolve in a given amount of solvent. You can't put one molecule more. You put any more, it won't dissolve. It will just float as a solid to the bottom of whatever container you're trying to do that. So that's solubility of a solute. Next, you should know types of solutions. A saturated solution contains the maximum amount. Remember up here, solubility just gives you a number. These types explain something about that solution. So saturated, you're at the maximum amount. You can't dissolve anything more. A dilute solution means you only have a small amount of the solute present in that solution relative to the amount that could dissolve. Now, concentrated, you have a large amount of solute, but you're not at saturation, but a larger amount of solute relative to the amount that could dissolve. Now, something really important you should know is an aqueous solution. And when you see aqueous solution, and I'll show you how it is abbreviated, that solution has water is the solvent. And it's abbreviated by bracket AQ close bracket. Now, an important concept when we talk about solutions is how much solute is in a given amount of a solution. How much solute? And we call that concentration. Now, I talked briefly about concentration by weight and concentration by volume. But in the lab, in a chem lab, and in a chemistry plant where Dr. White's worked, we use molarity. And you know something? I haven't been subtle all night. I think it's time for Dr. White to get subtle. Is that subtle? Hint. Know this. And you should know molarity, which is designated by a capital M, is the ratio of moles of solute per 1 liter of solution. However, 1 liter of a solution equals 1,000 milliliters. 1 liter is 1,000. In the lab, we use this one. Molarity is moles of solute per 1,000 milliliters of solution. And you should know, what does this mean? And for this one, question is, what does this mean? And what is the solvent of that solution? Well, as soon as you see capital M, that tells you molarity. And therefore, I know that this is 7.81. And remember, that's moles. And here's the solute, NaCl per 1,000 milliliters. So what does this mean? As soon as you see the capital M between a number and a chemical formula, that's molarity. Moles of solute, in this case 7.81 moles of sodium chloride per 1,000 milliliters. Now, what's the solvent? And that's where you have bracket, AQ, close bracket. That tells you it's an aqueous solution. An aqueous solution, the solvent is water. And this is something you should know. Now, it turns out molarity is very helpful in making what we call stock solutions. If you were to go into the stock room at COD, you see a whole shelf of bottles that have a label like that one. Some are for salt, for other things. So you can take and know how much of something that's already dissolved. And that helps you determine how much of a molecule or weight of a molecule you want to use. If it's a solution, you just measure out a volume. And notice here I have, what does 1.34 capital M mean? HCl. Molarity is capital M, moles of solute per 1,000 milliliters. In this case, that's 1.34 moles of HCl per 1,000 milliliters. And here, 7, I did similar with sodium chloride, so we'll skip that. Now, let's look at number 8. How many moles of sodium chloride are in 125 milliliters of a 3.45 capital M NaCl solution? Well, what are we trying to find? Moles of NaCl, sodium chloride, table salt. What are we given? 125 milliliters of the solution, and we're given this number, 3.45 capital M NaCl. What does that mean? Well, as soon as you see a capital M between a number and a chemical formula, that's molarity. And what it means is 3.45 moles of sodium chloride per 1,000 milliliters. Now, we want to find out how many moles of sodium chloride. That's the units we want to get to. We're only starting with this 125 milliliters of the solution. So if we have a ratio that can convert milliliters to moles, how do we do that? Use your good buddy, your good friend, unit analysis. Whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. And where do we get a relationship between moles of sodium chloride and milliliters? Right over here, by knowing 3.45 capital M NaCl, the molarity means moles per milliliter, 1,000 milliliters. And we put that in. Notice milliliters cancel out and we're left with moles. 3 significant, 3. The 1,000 is an exact number as part of the definition. And this is the answer we get. Now, in real life, how do you make up stock solutions, different molar solutions? Well, it's the two-step molarity problem. And step one, you convert milliliters to moles. And step two, you convert moles to grams. Now, I also have here, in case you need it, 1 mole of an element equals the atomic weight of that element in grams. 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of the compound is the sum of all atomic weights, which I hope you learned for test 1. Not you learned for quiz 3. This we're going through quiz 4. Now, one thing I neglected to tell you that I should show you right now, if you go to Blackboard lecture section, you'll find important information quiz 4 file. And on the last page of quiz 4, this is the information you will get. So let's look at one of these problems to determine how to make a stock solution. And if we look at number 11, we have how many grams of sodium chloride are needed to make 345 milliliters of a 6.789 capital M solution. So we're trying to get the grams of sodium chloride. We have milliliters of solution needed, we're trying to make. We have this number, 6.789 capital M NaCl. Well, as soon as I see the capital M, I know that's molarity. What this really means is 6.789 moles of sodium chloride per 1,000 milliliters. So how can I go from milliliters to grams in one step? You can't. You need 2 steps. And as I just showed you, the first step is you go milliliters to moles. Here I have milliliters. I want to go to moles. Eventually I'll get grams, but now sodium chloride. If I had a ratio to convert milliliters to moles of sodium chloride, what would be on top of the ratio? Whatever I'm trying to get to, moles of sodium chloride. What would be underneath? Milliliters. And where do I get this ratio? Right here from the molarity. 6.789 capital M really means 6.789 moles of sodium chloride per 1,000 milliliters. Put those numbers in, 3 significant, 4 exact number. Now, this is a 2-step or multi-step calculation. You can round off at each step like Dr. White does, or at the end. I calculate both ways, and if they're different, not the same, I give you correct full points. So this I'll round off to 3 significant figures because I'm a round off at each step person. Remember, when you multiply and divide, you get the same number of significant figures in your answer as the number that has the fewest significant figure. This is 3, this is 4, 1,000 is the exact number, 3 significant figures. So now I have 2.34 moles of sodium chloride. Am I done? No, we're trying to get the grams of sodium chloride. So the second step, moles to grams. I have moles of sodium chloride. I want to get the grams of sodium chloride. if I have a ratio that can convert it to moles to grams, what goes on top of that ratio, using your good buddy, your good friend, unit analysis, that's grams of sodium chloride. What goes underneath? The moles of sodium chloride. And where do I get that? And I just showed you 1 mole of a compound equals the molecular weight of the compound. So here I have 1 mole, and on the top here, grams of sodium chloride, I need the molecular weight of sodium chloride. And over here, MW, that's short for molecular weight of sodium chloride, there's 1 sodium and 1 chlorine. Remember, molecular weight is the sum of all atomic weights. And if you look on the periodic table, underneath sodium, you'll see the 3 significant figures, sodium 23.0, chlorine 35.5, added up, you get 58.5. And you put this in here, 3 significant, 3, 1 is an exact number, and you get 137 grams. And you get that both ways. Which reminds me, in one chemical plant, I had to do the calculations to make about, here we use gallons. And remember, there's 4 point, oh, I always forget, about 4 liters per gallon. And I had to make up a stock solution for a reaction of mine they were running, and they needed like 1,000 gallons of stock solution. Make sure you don't make mistakes calculating or you waste a lot of money, and that's not good for your future at any company. All right, let's go back and see if there's anything else to talk about. And the answer is no. Don't forget, this Thursday, I'll be giving quiz 4. It'll have until Friday, 8 p.m. to upload your answers. Remember, tomorrow, Wednesday, from 6:30 to 7:30 on Zoom, I will have my office hour. If you need help, stop by. Remember, I haven't said it in a while live, or just not really live if you're not here. Remember, in my class, there's no such thing as a dumb question. If you need help, reach out to me. I will always try and help a student any way I can. With that, I'm done. I'll stick around for a couple minutes afterward to answer any questions. But you know the ending coming up, gehen gesund, which is Yiddish, which means go in health. And goodbye now. Goodbye. I stole that from Granny to Beverly Hillbillies. Actually, on TV, she goes like this, goodbye. Bye now.